So you've looked at type 1 questions, you looked at type 2 questions, which is what this is. Now it's time for you to look at type 3 questions. Now the only difference between a type 2 and a type 3 is we are going to take this and we are going to move it off the ground like a type 1 question. So it's off the ground like a type 1, but it's being shot at an angle like a type 2. So it would look something like that. So this is a type 3 type of question. Okay, and again, if you can do type 1s and type 2s, there's no real reason you can't do type 3. Again, no new formulas, all the exact same type of calculations, just a different setup, different viewpoint. That's it. Okay, so we are going to look at type 3 projectiles and look at that type of question. So it's like we sort of laid out before, the initial height is not going to be equal to 0, and the initial angle is also not going to be equal to 0, and that's what I call a type 3. So something, just basic sketch, something like this, coming off an angle, so it goes up and then it comes back down. So that's a type 3 question. All right, now you can probably see a couple things about it. Let's go back to the simulation for a sec. Once again, if you look at this, just like in the previous video that we did and we used the simulation, there's a little green dot at the top, which is awesome. And if we shoot this thing again and we step to the top, the same way we did last time, get right to the top, and where's my velocity vector? There it is. Same thing we did last time. We're at the top of the path. The cannonball is moving perfectly horizontal. And that's it. So just like before, the second half of the question is, or second half of the situation is, again, just a type 1. It's going perfectly flat at the top. It's just a type 1 projectile question from the top all the way back down to the ground. But if you look at the first part, it's actually also a type 1, except it's just not symmetrical. So just like type 2s were a type 1 plus a type 1 symmetrical, this is a type 1, just not symmetrical. But it's the exact same ideas, the exact same calculations, you just can't transfer some of the information from one half to the other half as easily. But it's the exact same idea as before. So once again, it's great if you split it right at the top. And this part right here, this would be a type 1, and this would be a type 1. So once again, we have two type 1s, but there's just no symmetry. So once again, if you do type 1s, there's no real reason why you can't do a type 3. Okay, so it all just works out the same type of thing. So go back to this. We can actually play it again. Play. There we go. All right, something like that. Fire again. So what we'll do, you know what, we'll just start. Best way to do it is just start with one of these questions, start at the beginning, work our way up around here. We'll take the ball, cannonball, have it go on the way up, find stuff on the way up, and then we'll find stuff on the way down. Best way to do this type, or learn this type of question, is just to jump in and actually do it. Okay, so that's exactly what we're going to do. So let's just take something, we'll go back here. All right, so we'll clean this up, give ourselves a little bit more room. Clean that up. Okay, so really simple. Get a little bit of a cliff, just like in the simulation. Okay, and the cannon was up here, something like this. Just the cannonball, and the cannonball is going to go up and then come back down. And I think it was, we even used the same thing. Let's say it's 5 meters off the ground. I believe this was 60 degrees. And it was shot at 16 meters per second. Now let's just work through the scenario and just solve for everything. So the same as in a type 2, typically the first thing you want to do if you can is find the Vx and find the Vy, because you know the X stuff and Y stuff are used for different things. So the first thing we'll do is we will break those apart. So 16 cos 60, that'll give us 8.0. And then if we do the 16 sine 60, we get a Vy of like 13.9. All right, so there's my V's broken apart. So let's just forget about the second half. All we're going to do is work our way up. So let's worry about just going on the way up. Well, I've got the Vy. So probably the easiest things to do would be to find the time up. So the time up would just be my delta Vy divided by G, and I can find how long it takes to go up. So if I divide the two out, get around, about 1.41 seconds to go up. And of course, that's just the time to go up. It's not symmetrical, so it's going to take more than that to go down because it is farther. Now, it would take 1.41 to get to that point right there in the second half, but that's not what we want to do. Okay, so let's find out what else we can do on the way up. We've got the time up, so then I can find the distance up. And if I find the distance up, that's just the 1/2 gt squared using the time up. Works really, really well for that. So if I do that, I can find out that the cannonball went 9.8 meters up. Now that is the distance up from the cliff, whatever you want to call it. So that's just this distance right here would be 9.8 meters. Well, if I knew it started at 5, that means I can just add the two together. Start at 5, went up another 9.8. I can then get my maximum height, would just be the combination of those two. Got the 5, got the 19.8, so that's 14.8 meters is the maximum height of my cannonball. Okay, that's all the stuff on the way up. So now let's bring it back down. And when you bring it back down, we're literally just, it's a type 1 question from a height of 14.8. That's all it is. So a nice thing to do would be to find the time on the way down. And if I find the time on the way down, the 1/2 at squared comes in really nicely. So it'd be 2 times the maximum height divided by g square root. So just the 1/2 at squared expression. And then we can find out how long it took to go down. And we know it's going to be more than 1.41. And when we punch that out, we get like all around 1.74 seconds on the way down. So that was my time down. So with that now, I do have my time up of 1.41. I do have my time down of 1.74. So, I mean, just those two things alone, I know that my time of flight would be the combination of those two things put together, which would be around 3.15 seconds. That's my time of flight. So other things I could find on the way down, I know that the height down is just the height maximum, but I could find the Vy down. So my delta Vy on the way down would be g times my time down. So it's using VAT again, but only using the time down. So if I use that 1.74 times the 9.81, I can find out that my Vy on the way down was 17.1 meters per second, which makes sense. The initial Vy was around 14 on the way up, and since it's falling a lot farther than it went up, obviously the new Vy is going to be greater. So again, losing a little bit of that symmetry. All right, so there's all of my up stuff. There's all of my down stuff. I got my total time of flight. Well, let's see what other total things I could do. Easiest one's probably my range. My range would just be dTV, and I would use the total time. So I'd use that 3.15 that's right there. So if I take that 3.15 and multiply it by my Vx, which is the 8, which never changes, we get a range of about 25.2 meters. Okay, so there is my range for the entire thing. Really, the only thing left would be the final velocity. That's the only thing that's really left. But again, same type of thing as we've done before. I got my Vx, that never changes, so that was 8. My Vy, I would use my final Vy when it hits the ground, which is 17.1, and then I can just solve for my hypotenuse to get my overall velocity when it hits the ground. So if we do a little Pythagoras and stuff like that, the impact of velocity looks like around, it's going to be around 19 meters per second, and then we'll solve for the angles, so like 17.1 and the 8, and I like to use tan theta for this. And if we do that, we're looking at around negative 65 degrees. So that would be the final velocity or impact velocity of it when it hits right there. Okay, so that's a type 3 question. So it looks like it's a bunch of stuff, but it's the same steps over and over and over again. There's nothing really new, different, or blah, blah, blah. It's just the same type thing. You just take one piece, to find the stuff on the way up, piece things together, find things on the way down, look for total stuff. That's basically it. But again, no new calculations, no new quantities, just a different type of perspective or setup for the initial thing. So let's try another one here. Let's try this. Let's draw. Okay, so like some rocks, something like that, something like this. Down here, we're going to have some water. And we've got the guy over here. Something like this. He's run, and then he jumped up, and he's going to fly up and splash into the water. Okay, and let's say a little ridge or cliff or whatever you want to call it. Maybe it was 4 meters tall, and let's say he landed 9 meters away, and let's say he went another 3 meters up. So we're just going to give you a bunch of distances and stuff like that. So let's see if we can use this and piece things together, and we can find out a few things. Then maybe we'll look for his, what was his initial velocity that he jumped at. So if we go back to this, of course, type 3s are all about just, breaking it up at the top, find stuff at the beginning, find stuff at the end, and we'll just sort of map things up, no problem, and just tie things together. Ooh, 2 cannonballs. All right. So look at the information we're given, see what we can piece together, and we'll try and solve the situation. So we got the guy jumping off. We've got a lot of distances in this one, so let's see what we can find with all those distances. Obviously, I've got the 4 there and the 3 there, so then my maximum height would be 7. So I've got a maximum height equal to 7. And of course, with that, I could easily find the time all the way down. So again, I'm just going to try and find some pieces and then sort of like work with everything and put it all together. So maximum height of 7. So if I did my maximum height is equal to 1/2 gt squared, that would be the time down. So I can plug all this stuff in there, I can find the time down, and my time down is around 1.19 seconds. Okay, so I've got that. I could find my time up because I can do the exact same calculation except with only the 3 meters. So I could do the height on the way up, 1/2 g time up squared, to just see how long it takes him to go up that 3 meters. So if I do the same type of calculation, I can find the time just to go up. I know it has to be less than 1.19 seconds. And I get a time up of 0.78 seconds. So using the same calculation, the 1/2 AT squared type calculation, 0.78 on the way up, 1.19 on the way down, and then I could actually, put them together. My whole time of flight between the two would just be the combination of the two. So my time of flight would just be the sum of those two put together, which is going to give me around 2 seconds. Yeah, it's like 1.97 seconds would be my time of flight. Okay, so that's just finding times. And times are a really good thing to have in projectile questions because they link to lots of different things in both the X and the Y components. Okay, well, I've used the 4, I've used the 3. I still haven't used the 9. So if I did the 9, that's my range. With my range, I've also got my total time. I could find my Vx with that, basic DTV. So Vx would just be my range divided by my time of flight. So I've got the 9, and I divide that by the 1.97 seconds, and I will get Vx of around 4.6 meters per second. So there's my Vx. And that never changes. So I've got my Vx for the beginning when he took off. So my Vx was 4.6. I see the Vy. So to find the Vy he started with, I've got the distance up. I've also got the time up, though. I found that, so I can use that. That could come in handy. So if I have the time just to go to the top, I can use my change in V equals AT. So it's going to be change in Vy going up is going to be G time up. So it's basically VAT. Typically, we've used this to find the time up, but now we're actually using it to find the delta Vy on the way up. So if I take that 9.81 and I multiply it by the 0.78 seconds, we're looking around 7.7 meters per second was the initial V in the Y direction. So going up was 7.7. So again, just finding pieces, one links to another. Well, I've got my initial Vx, I've got my initial Vy. I can then use them to find out what his takeoff velocity must have been. So using good old Pythagoras, we get a V of around 8.9, and then we will find the angle. We've got the 7.7, we've got the 4.6, and this ends up being like 59 degrees. So put it all together, the initial velocity must have been around 8.9 meters per second at 59 degrees for him, for him to go up and then go splash into the water, something like that. Okay, so there's another basic type 3 question. Again, no new calculations, some DTV, some VAT, just put the pieces where they belong, map things out, label them, whatever you need to do. I can color code on this thing, makes it a little bit easier for up and down stuff and different things. But just use subscripts, keep organized. I often like to put my quantities on the diagrams and draw them where they belong, and it just makes things a little bit easier for myself to keep things organized. But again, basic calculations, no new formulas, just a different type of setup.